Alright, if you guys could please turn to 2.5 Graphing Techniques Transformations. This is the last section of this unit. Vertical shifts. If you have a function and you add a number to that function, it's going to go up.
Jenny, vegetables tri-tip.
K units. If you subtract something, it's going to go down. Okay? So this was when you added K units. Nah, you don't even have to put units. This is when you add K. This is when you subtract K. Horizontal shifts. If you add something to the x inside the function, it's going to go to the left. Okay. If you subtract something from x inside the function, it's going to go to the right. And once again, this is when you replace x with, you know what, I think I'm going to change the variable here. I'm going to use an h instead, just so it doesn't get confusing. And this is when you replace x with x minus h. Okay. Compressing or stretching. When we have, let's do this. And when you have your function times some number, a is bigger than 0, or if you multiply the x itself by some number. Once again, this is if a equals 0. In this case, you're going to stretch the y coordinate by a multiple of a. And here you would stretch the x component, or sorry, the x coordinate by a multiple of a. Okay. And once again, this is when you multiply f of x by a, and this is when you replace x with ax. Okay? Reflection about the x-axis. If you make it negative, it reflects about the x-axis. Okay, reflect about the y-axis. If you make the x inside the equation negative, it reflects about the y-axis. And this is when you multiply f of x by -1. And this is if you replace x with -x. Okay, so, for example, use the graph of f of x equals x to obtain the graph of h of x equals x squared minus 4. Okay, you know the graph of f of x equals x squared looks like a u. Okay? If you subtract 4, I'm going to move it down 4. And so it looks like that. Okay, I'll let you guys go ahead and try this one. Alright, now this one, okay, so it looks like that. This one, let's see here. We're subtracting 5, so I'm going to move it down 5. And I'm adding 3, so I'm going to move to the left 3. So here's my graph. Whoops, except it goes through that point. Alright, and you guys can go ahead and try this one. This one's actually very difficult. If you have trouble with it, let me know tomorrow. You have to put this in vertex form, which you guys learned in Algebra 2, but it's been a while. So once again, if you don't know how to do it, do your best, and we'll go over it tomorrow. Alright, example 3. The graph of y equals f of x is given in the figure. Use this graph to find these two graphs. Alright, excuse me, hiccup. And you know what? I think I'm just going to let you guys graph it right on here. Y equals 2 of f of x. Everything is just going to be multiplied by 2. So if this is 2 and this is negative 2, it's going to be here, going to go down here, going to be here, going to go down here. And everything is the same except it's stretched so that it's doubly tall. Okay? So that would be the first one. I'll go ahead and try to graph it. Your graphs do not have to be beautiful. They just have to be accurate. Actually, you know what? Don't worry about that. I'll just say it's in red. You guys are welcome to graph it right on the graph and just label it. Or if you want, you can graph it separately. Either way is fine with me. I don't mind.
Why?
Okay. When you multiply the x inside the equation by something, each of these are going to be multiplied by 3. Alright, so basically it's just stretched horizontally. Okay, and then it would continue on. But something like that is fine.
Not exist because I'm not adding them.
Great idea. Okay. Because my mom and sister asked if it's okay if they have a plus one.
Alright.
The one I
Alright. Example 4. Find the function that is finally graphed after the following 3 transformations are applied to this graph. Okay. So, let me switch back to blue. If you shift it left 2 units, that means you're going to subtract 2 inside the parentheses. If you shift up 3 units, that means you're going to add 3 inside the parentheses, or sorry, outside the parentheses. And if you reflect about the y-axis, that means your x becomes negative. Okay? And I left you a lot of space because I thought that you had to graph it, but I guess you don't. So, that's the answer. You guys can go ahead and try you try. Alright, this one. Graph the function f of x equals 3 over x minus 2 plus 1. Okay, so you know the graph of 1 over x looks like this. If you add 1, it moves up 1. If you subtract 2 inside the parentheses, it moves over 2. Okay, so here are our new asymptotes that we're going to follow. And we're multiplying by 3, but it's difficult to demonstrate the stretch of, just go ahead and graph it regular, and just keep in mind that it is technically stretched. Okay, there you go.
By the way, I had a concern.
The domain and range of f. The domain, it goes from negative infinity all the way up to 2. Or sorry, negative 2. And then from negative 2 to infinity. And the range goes from negative infinity all the way up to 1. And then from 1 all the way to infinity. Alright?
We're just about ready. Dad's just testing the doneness of...
Okay, last example. Graph the function and find the domain and range. Okay.
Just put it over there next to the sink, Kathy.
When you graph this, you guys know that root x looks like this. I'm going to add 2. outside the parentheses, add 1 inside the parentheses, and the x is negative. So it looks like this. The domain is negative infinity to 1, including 1, and the range is 1 to infinity. Okay? And that's it for this section. You know what? I think at the beginning of this section I said this was the last section. I don't know what I was talking about. There's one more section, but this section is actually really short. Okay? That's it.